In this final part of the chapter, we're going to look at how to draw probability trees when events are not independent. So when the events are dependent on each other. So let's suppose we had two events A and B. Then the way that we can think about these events happening or not happening is we could draw a probability tree. Well, let's start with A. Either A could happen or A doesn't happen. If A happens, then either B could happen or B doesn't happen, B dashed. And similarly, if A doesn't happen, then B could happen or B could not happen. So the probability of A, let's just leave that as probability of A happening, and the probability of A not happening, we can leave that as probability of A dashed. And remember that these two probabilities will add up to 1 because either A happens or A doesn't happen, so they must add up to 1. Now, normally we would just put the probability of B here on this branch and the probability of B here on that branch. Well, we don't know that these two probabilities are going to be the same because that would only be true if the outcome of A happening or not happening doesn't change the probability of B. So really what we need to put here is we need to put, well, this is going to be the probability that B happens, given that we've gone down this A branch, given that we know A has happened. Similarly, this branch is going to be what's the probability that B happens, given that we know that A hasn't happened. And similarly here we can put that's the probability of B not happening, given that we know A has happened. And again, those two branches will have to add up to 1. And here we're going to have the probability of B not happening, given that we know A hasn't happened because we've gone down that A dashed branch. A hasn't happened. And again, those two probabilities will have to add up to 1. Now, if the events were independent, then let's just write this down. If independent, then the probability of B given A has happened is just going to be the probability of B. Because the fact that A has happened doesn't change the probability of B happening. And if you wanted a bit of a proof of that, you could use the formula for conditional probability. The probability of B given A is equal to the probability of B and A happening divided by the probability of A happening. Now, because these events are independent, this probability in the numerator, because of our definition of independence, you can just times together the two separate probabilities and then divide by the probability of A. So you can see that the probabilities of A are going to cancel and you just get the probability of B. So that's only true if this is independent. So in general, we're going to have to work with these different probabilities that will change depending on which branch we've gone down. So let's look at a specific example. So we've got a bag containing 6 green beads and 4 yellow beads. And the beads are taken at random and the colour is recorded and it's not replaced. This is going to be really important when we draw our tree diagram. The second bead is then taken from the bag and its colour recorded. Given that both balls are the same colour, find the probability that both are yellow. Right, so this is quite a complicated situation. And what we try and do when we've got a complicated situation in probability is we try and draw a tree diagram to try and help us think about it. So the first choice that we've got is what colour is the first bead going to be? So our options are the bead could either be green or the bead could be yellow. So this is the probability of 6 out of 10. So that's 6/10. Because 6 of the beads are green and 10 of them are in the bag in total. And these two have to add up to 1. And we know that there's 4 beads out of 10 that are yellow. And then we can do a similar thing for the second bead. So once I've chosen a green bead, when I choose my second bead, I can either pick out a green one or a yellow one. And similarly, if I picked out a yellow bead first, then for my second bead, I could have either a green one or a yellow one. So this here is the probability of getting a green on the second bead, given that we've chosen a green in the first bead. So we've got to try and work out what that probability is. Well, we know that there's 9 beads in the bag when I'm choosing my second bead, because I've taken one out and I'm not replacing it. And I've got to work out of those 9, how many green beads are there. So we started off with 6 green beads, but because we've taken one away, because my first bead was green, if I'm on this branch here, I know that there's only going to be 5 green beads left in the bag. And similarly, there's 9 beads left in the bag still, and the number of yellow beads, so the probability of picking out a yellow bead second, there's still going to be 4 yellow beads left, because I haven't taken out a yellow bead out of the bag, and we should just check that they add up to 1, which they do. Similarly, if I pick out a yellow bead first, then there's going to be 9 beads in the bag, and out of those 9 there's going to be 6 green beads, because there's still 6 green beads in the bag. I've not taken one out. And similarly here, this is going to be 3 out of the 9 are yellow, because we started off with 4, we've gone down the yellow branch, which means we've taken a yellow one out, so we have 3 out of 9. And it's worth noting down, what are these outcomes? So this is the outcome that I take a green bead first and then a green bead second. This is the outcome that I take green and then yellow. This is the outcome that I take yellow and then green. And this is the outcome that I take yellow and then yellow. And we can actually work out what's the probability of ending up with each of these outcomes by just doing by timesing along the branches. So we know the probability for getting a green first followed by a green second is going to be this probability multiplied by that probability. We always times along the branches. So this is going to be 6 tenths multiplied by 5/9. And I'm going to say that's the probability of green, green. So that's 30/90, or a third. We can also work out what's the probability of getting green first then yellow. So 6 tenths times by 4/9. So that's 24/90. Yellow and then green, etc. So we want the probability that given that both balls are the same colour, the probability that both are yellow. So we're going to look at 2 different ways of doing this. First of all, let's just think about it intuitively. So we're restricting ourselves to only some of these outcomes. We know that both balls are the same colour. So we know that we are either here or here in our diagram. So the total probability within the region that we know we're in is, add the 2 together, 42/90. So the question then becomes, out of those 42/90, where do I need to be in order to ensure that both are yellow? Well, that's 12/90 out of the 42/90. And we can simplify that by timesing the top and the bottom by 90 to get 12/42. So that's the probability that we were asked to find. Now we could use the formula for conditional probability. If we did that, it's going to get a little bit complicated, but let's have a look at it. So we want the probability that both are yellow given that both are the same colour. So if we were to use our conditional probability formula, that would be the probability that this happens and this happens. So the probability that both are yellow and both are the same colour, divided by this event happening, the probability that both are the same colour. Let's look at each of these probabilities then. So the probability of both yellow and both the same colour. Well, the condition that they're both the same colour is satisfied because they're both yellow. So saying that they're both yellow and they're both the same colour is just the same as saying that they're both yellow, because immediately we know that they're both the same colour. So that's 12/90 on the numerator. Yellow, yellow. Divided by the probability that they're both the same colour, well, we'd have to add together the probability of getting green, green and yellow, yellow, which we did before. And we worked that out as 42/90. And we get the same answer, 12 out of 42.